All right, now we're going to be working on the new unit, the last unit that you had to do on your own after you went home for Thanksgiving. All right, so let's take a look at that. So that deals with systems of equations, of linear equations and inequalities. Okay, and so we'll do several of these. All right, I don't think I'll do 38. You would just graph both lines on the same coordinate plane. So pretty much what I did when I showed you the graphing, and you would just look for the point of intersection. Okay, let's go ahead and get right into using the algebraic methods for solving. So these problems ask you to solve. I'm just going to take a collection of these to do. All right, so let's look at, let's go ahead and do number 39, and we'll look at several of them. All right, probably if the x and the y are on the same side like they are here, your thought would probably be to use elimination. Okay, I'm not teaching you how to do this. There's videos that teach you. We're just using them to do several examples. So if you're going to use the elimination, which is sometimes called the addition method, you tweak the equations, you adjust them so that in front of one of the variables you have opposites. So since the x looks like all I would have to do is get a 2 right here, that's the one I would eliminate. So what I would do is multiply the top equation through by 2. Make sure you go all the way through both sides. So this becomes 2x plus 18y, and that would be negative 78. Okay. And then the other equation on this particular one, we didn't have to do anything to it. It already had the negative 2 sitting there that would make it work well with this, because at this point I'm getting ready to add, and when I do, that's going to be a 0. This is going to be a 26, and over here I get a negative, what is that? Negative 10, negative 130. Two negatives don't make a positive when you're adding, so make sure you're careful about that. And then you're going to divide by 26, and then when you do, you wind up with y equaling negative 5. Okay. After you find one of them, you could go back and eliminate to find the other variable. You could just do it again using an 8 on top and a negative 9 on the bottom. The typical approach is to pick one of the equations. So maybe I'll pick that top one. And I know that y is negative 5, so I'll plug that in. And then that would give me 45 minus 45 there. Then I would add 45 to both sides. And I would wind up with x equaling 6, okay? And then the 6 is the x, and the y being negative 5 means I'd put a negative 5 there. Now, these are very easy to check, so if you have time, you would do that. You just put a 6 where the x is and a negative 5 where the y is. Make sure that's negative 39. Do that here. This is what you're claiming, is that ordered pair works on both. So try it. Make sure it works on both. And so that would be 6 plus 46 minus 45, which would work. This would be negative 12 minus 40, which would give you negative 52. So it would work. So I know for a fact that's right. Okay. All right. So let's look at another one. I'm not going to do them all, but let's try several of these. Here's one where one equation's in slope-intercept form. The y is already by itself. So that one is one where I might want to do substitution. And so I know the y's have to be the same at the point of intersection, and that's what I'm looking for. So 1/2 x plus 3, I'm going to put it right there where the y is. Right there. I'm going to put the 1/2 x plus 3. Okay. All right, so what's going to happen then is from here to the end, I'm just going to need to solve for x. So I'm going to distribute, get x minus 6 equals negative 6. And I was expecting to have an x left, but 1x minus 1x, that's 0. I just have -6 equals -6. My variable canceled out. This is a special case. So the variable canceled out. Variables are gone. Okay, you got a 0 right there. Okay, you didn't get an x left. You got a 0x, which is 0. And so this right here is a true statement. So that means when you're thinking about which of these it is, it's this one. Okay, it's this situation, which would have infinitely many solutions. Okay. And if you wrote it formally, it would be the set of all ordered pairs that satisfy the equation, and you would just put one of those equations in there. Okay. So your answer would be this one. Okay. All right, so that one turned out to be a special case. All right, let's go on and look at maybe one or two more of these. So what about one like 43? Oh, before I do that, if instead of it being -6 equal -6, if you had, this is a what if you wound up with the variables going away and getting something like 0 equals -5, something false, then it's not this, it's this in the middle here. And you would have no solution since there's no point of intersection. That would be your answer, no solution. All right, I'm not going to do another one that has a special situation. Let's look at 43, a nice normal one like 43. Okay, on this one, you're being asked, remember to solve. This one has the x and y on the same side, so I think it would be nice to get rid of, to use elimination to get rid of one of the variables. I think you could get rid of either of them pretty easily. A lot of people do better when they get rid of the x because it's right there. See how I could, oops, I meant to bring a 4 up. See how I could bring a 4 up and a 9 down and just make one of them negative? So the top equation becomes -36x minus 28y, positive 36x minus 28y equals positive 240, 268. The bottom one becomes -36x minus 18y equals -360. Okay, so you could have eliminated the y's if you prefer, or you could just get rid of the x's. If you did what I did it because the x's would go away. I'd have -30, -20, 30, 46y. And then here, one's negative, one's positive. So I'm going to wind up having a, what would that be? If I'm trying to subtract. I don't have my calculator here and I don't want to mess it up. So I'd wind up having 292. Is that right? Yeah, a -92 at that point. All right, and then I need to get rid of the -46. So I'm going to divide by it so that I get y by itself equals negative divided by negative would be positive, and that would be +2. All right, now you could go back if you wanted and just eliminate the other variable. Some people like doing that. Okay, to find the x, or you could take one of the equations, so maybe take the one that's all positives, and then just plug 2 in for the y. Make sure you plug it in for the appropriate variable. So that's 4x plus 2 times 2 would be 40. So 4x plus 4 is 40. So when I take away the 4 and divide by 4, I wind up with my x being 9. So when I write my answer, I'm going to put the 9 together with the 2. Now to check it, actually a quick check is just to use the equation 9x minus 7y, the one you didn't use the first time. The 9x minus 7y equals 67, and plug in the 9 and plug in the 2 and see if it turns out to be 67 like it's supposed to. Okay. And yep, it does. So I used this one to get the second coordinate, and then I checked by plugging into the other equation. So that 9, 2 must be the point of intersection. Okay. So that's all there is to the algebraic solutions. Okay. So I'm going to post this and then I'll do one more with word problems and inequalities.